Welcome to the introduction to the COBOL programming language. My name is Philipp Brune from Neu-Ulm University of Applied Sciences. We have mentioned COBOL several times during this course already, and COBOL plays a very important role on the mainframe platform. And as you can see from the history of higher programming languages, COBOL is one of the earliest higher programming languages, originating even from the 50s and then standardized in the early 60s. So it has been even around before the first S360 mainframe appeared. And since then, it has been an important or the important language for business application development. COBOL stands for Common Business-Oriented Language, and it was designed from the beginning as a tool even for business people to use computers and to do data processing, business-oriented data processing. And up to today, it remained an important language for writing business applications, because there have been so many applications written in COBOL that are still running, are still around. And COBOL has some advantages. It's very, very optimized for the processing of data, very resource effective, and therefore there are some reasons why COBOL is still a very important language. One is, of course, that existing applications, where large amounts of money have been invested over the decades, have to be continuously further developed, sometimes re-engineered, sometimes modernized, combined with more modern technologies like Java or JavaScript and so on. And on the other hand, there's even sometimes new development of new applications that is done in COBOL. COBOL, of course, is a typical business language that in a modern multi-tier architecture is typically used for the business logic, or sometimes called application tier. So it's on the business logic level. COBOL was first standardized in 1960 as the so-called COBOL 60 standard by the Conference on Data Systems Languages, CODASYL, which is was an initiative of the American government to the US government to standardize these languages. Later on, the standardization was taken over by ANSI and ISO, and nowadays it's an ANSI and ISO standard. The standard has evolved, and different releases have been proposed. So there's a standard version COBOL 74, COBOL 85, relating to the respective years, and COBOL 2002, which then also the COBOL 2002 version contains an extension to make COBOL also object-oriented. It's a OO-COBOL. However, the compilers, especially on ZOS, typically are based on the COBOL 85 standard. So this is the non-object-oriented version, and that is the one that is most important for development still. On a mainframe, COBOL is typically used for the two main classical purpose and tasks that a mainframe does, namely transaction processing applications and batch processing applications. So COBOL is used as part of transaction processing monitors. We will see that later in the chapter on transaction processing to write transaction processing applications, and it is used to write batch processing applications that in the background process large volumes of data, typically. COBOL is a very old language, very early, coming from the early times of computing, and therefore it is a bit, for modern eyes, a bit strange to understand that the structure of COBOL is still governed by the original structure of a punch card. And for beginners, this is something you have to get used to. In COBOL, every line of code is following a strict structure regarding what is allowed to write in which column. And every line has at maximum 80 characters corresponding to the 80 characters that fitted on a punch card. And this corresponds in ZOS to a data set with record length 80 and blocked, so fixed blocked 80 characters record length. The line structure is as follows. So the first 6 columns are reserved or not used. They can be used to put in a sequence number, which is optional. Then there is the column 7, you can see it here, this is column 7, which is a control column. This can either contain nothing, then it's a normal line of code. It can contain a star, then it indicates that the rest of the line is a comment, a source code comment. And it can contain alternatively a minus sign, which indicates a continuation line. So a line starting with a minus sign in column 7 is a continuation of the previous line. The columns 8 to 11, so the first 4 columns that are then actually source code content, are called the A area. And some statements have to begin in the A area, division statements, procedure names, and so on. And the rest of the columns 12 to 72 is called the B area, and it contains all the other instructions and statements of COBOL. Columns 73 to 80, so the last 8 columns, are reserved again, and they may be used by source code version control systems, for example, to store some markers or tags in that. So basically we can use for the actual code the columns from 8 to 72. And the COBOL compilers are on ZOS are rather strict about this. There are also other COBOL compilers that are a bit more loose regarding formatting. Maybe, for example, the GNU COBOL on Linux. So in general, we should keep to that structure. On the other side, the COBOL source code is organized into divisions. So now we look at the flow, at the syntax of the COBOL. And the COBOL code is organized in maximum 4 divisions. The general idea of COBOL syntax is to have it look like English language. That was the intention also of the inventors of the language, because they wanted it make it readable for business people. And this makes COBOL a very textual language with a lot of words. And it also follows the idea of being like an English text, like a book chapter or something. So it has a structure containing divisions, and then these divisions are separated again into sections, and these sections are then divided into paragraphs, so like you would organize a document. And the 4 main divisions are the identification division, the environment division, data division, and procedure division. In the identification division, some metadata of the program is given. Important and mandatory is only the so-called program ID. It's the name of the program. That is then also used on ZOS as the member name of the file or the binary. The environment division, which actually describes, for example, input-output structures like files that should be opened. The data division, which describes the variables in the data, so it is the division describing actually the storage, and then the procedure division, which contains the actual imperative statements, the statements that process the data. The division statements always start in the A area, and they are terminated by a dot. In general, all elements of the language are terminated by a dot, so the dot is the similar to the semicolon in C or Java. And again, a dot at the end is like in the natural language, where a sentence is also terminated with a dot. On the right-hand side, you see a simple example program that illustrates this. So it's a program that calculates basically an interest rate. And here you see the identification division with the program ID interest rate, the data division containing the working storage section. Here the variables are defined. So in the data division, there's the most important and typical section is the working storage section, which describes all the variables. And then there's the procedure division, and here's the actual instructions. And you see that the instructions themselves start in the B area. So here is the B area, the A area, and this is the B area. So we have the indentation of 4 characters here. And I marked the data division with a gray background to distinguish the different divisions. Okay. So this program basically does the following. It displays, so this is a write instruction, it displays an amount or text on the screen that the user should enter the amount. And it displays It asks for a duration, and the user needs to give or enter the duration. The accept statement reads an input of the user from the console, that part. And then there's a loop indicated by perform. So the loop runs for the number of years and adds the interest rate on the amount, and at the end it displays what amount the user has after some years of investment. Okay. And let's have a closer look on variables. So the first thing that we see also on the program on the previous slide is that all the variables are declared in the data division, and this means that there are only global variables. COBOL does not have the idea of local variables and no parameters and things like that. So the only way of structuring a COBOL program is to have some sections and paragraphs in the procedure division that can be jumped to, so it's like a jump mark, a jump label, but not a real procedure with a local storage or stack or recursion is also not possible. And the data division contains all variable definitions, variable declarations. In the working storage section, we have the normal variables that are global variables for program execution, and you see that this is a simple example showing some different type of variables. This one is an elementary variable. It's started with 77. So every variable declaration starts with a number that is sort of a level indicator. And for the top level variables, this level indicator has to be given in the A area, where the name of the variable and all the rest then is in the B area. Okay. And if a variable on the top level starts with 77, it's an elementary value. And if it starts with a number of 1 or higher, then it's a record structure. And the substructure of this record then starts always in the B area. So there is a level from 1 to 45 at maximum, indicating the indentation or the level of the hierarchical structure. And this allows to specify data records with a hierarchical structure, which is very important for business applications. For example, just think of a customer record, as in this example. Customer number, name are part of the customer record. Okay, so this can be compared to structs in C, for example. And you see that the second number already is 5 here. Of course, it could be also 02, but usually one makes larger steps, so it's easier to insert later if you modify something another level. Important is also how the variable is declared. So cust_rec is a structure, but then we have inside the structure we have two elementary variables, and they are declared with like all variables with the so-called pic clause, the picture clause. The picture clause specifies the data type. So this is the name of the variable, this is the picture clause specifying the data type. And the data type is specified not like int or double or something, but it's specified in a picture way. So you basically describe how the field should actually look like. And you see, for example, this is a field that has 4 digits, and the one with the X is 40 characters, for example. So the picture clause defines the type and the format of the value, the length of the value, and the numerical accuracy. And this is mapped usually internally using BCD arithmetics. The syntax is like this. So it starts with the variable name. I've seen it. And then there's the keyword pic. And then there's a symbol. And the symbol indicates sort of the type. Then the length or the number of elements. And then we have some additional switches here to achieve, for example, binary, not BCD arithmetics. And then we have optional the value, which allows to provide an initial value. And then we can also specify arrays. Arrays in COBOL are always of fixed length, and this is done using the occurs keyword. Occurs and then times says how many elements this variable represents as an array. Okay. For symbol, for the type, there are different options. We have seen already X is for alphanumeric characters, 9 is possible for digits, for BCD numbers, for example. S indicates a sign inside this format string, and the V indicates the decimal separator. Regarding the statements of COBOL, these are some elementary imperative statements. The add statement adds, the move statements is the value assignment. It moves a value from one variable to another one, or a value inside a variable. The inspect is for string. We have seen display and accept. This is input-output on the screen. We have write and read. That is for reading from a file, from a data set. Close and open for accessing, opening, closing a file. And at the end of the program, there's a stop run command that terminates the actual program execution. So these are some common typical elementary commands, statements. And this is then, of course, we have control structures as well in COBOL. We need the usual conditional statements and the loops. And regarding the conditional statements, we have the typical if-then-else statement. And you see that all the control structures, the block structure of the control structures is terminated by an end-if, or the evaluate statement is like the switch case in C. It's the multiple condition, evaluate and evaluate. And here for the loops, all loops are indicated by perform. So perform, the keyword perform, can do different things in COBOL. It either is a call of a paragraph, a jump of a subroutine to a subroutine, or it is a loop. And the different loops all start with perform. It's a bit different from more modern languages. So for example, this is the counting loop, perform n times. And this is the conditional loop, perform with test before or after. This would distinguish the while or the do-while loop, and with a condition here. Okay, so that is the syntax. One important thing is that it's always confusing for beginners. The dot terminates a statement, as in a natural language. We learned that already. But inside a block, for example, if you would have a hierarchical embedding of one control structure in another one, inside the outermost control structure, you do not put any dots anymore. And this is different, for example, from C or Java, where you put the semicolon inside inner blocks as well. Okay, so this was a short overview on the features of COBOL, and we will come back to that when we have a look on transaction processing later, where we see how COBOL is used in the context of a transaction processing monitor. Thank you.